Okay, so let's get into what we're going to do today, talking about the ambiguous case of the law of signs. Okay, and we're also going to introduce law of cosines as well. Okay, so we'll examine the ambiguous case of the law of signs and also intro the law of cosines too. Okay? All right. So, first of all, how do we clue ourselves in to whether or not we are needing to look out for this ambiguous case of the law of signs? Okay, how do we clue ourselves in? The key thing to remember is to kind of take a look at your triangle, right, and to see whether the given information about that triangle, all right, is a triangle congruence, which if you remember back from geometry, right, it'd be side, 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 angle, angle, or angle, angle, side. Those for arcus, hypotenuse, leg, but that'd be a right triangle, and we wouldn't need to worry about that. So the ambiguous case of the law of signs only occurs, and this is the key, so I'm going to put this star here. This only occurs, okay, for side, side, angle, triangles. Side, side, angle triangles. Because we can use law of signs to solve a side, side, angle triangle, right? But side, side, angle does not guarantee a unique triangle, okay? There's sometimes a case where you can actually get two possible triangles from this given information, or there's a case where you can be given this information and no such triangle could exist, okay? So, let's examine that. The first case we're going to look at here is going to be the no solution case. I think that'll be the easiest one to kind of see here. Okay, and this one's nice because I don't want to say it's idiot proof because I don't want to make cult names or anything like that. But the idea is that basically it will kind of present itself that there will be no solution when you run across a situation like this. Okay, so what do I mean by that? Well, let me start with a triangle here. So again, let's just say our example here is to, solve the triangle. Okay, and I'll just go ahead and draw our triangle and label it for us here. Okay, a little pizza slice again. And so if we want to solve this triangle, right, there's no real choice that we have about how to solve this triangle. There's no choice. We have one way to set it up. In the warm-up, right, we had a little bit of choice, right? So Jessica chose to solve for the angle first, or at least for us, she chose to solve for the angle first. And then later we had, Ellie and Robert that then solved for the sides. Did they have to do that? No. We actually could have solved for, I think, side B first if we wanted to, right, and then gone and solved for the angles. But here there's only one way to set this up, so there's no choice involved. We have to start with our angle and opposite side here, so sine of 85 over 15. So again, there's no difference here. It's just like what you would normally do. And then we would say that's equal to sine of angle B over the side opposite B there, the 25. Okay, so we have to start here. Right, and so to solve, well, it's going to be sine of B. If I just multiply the 25 over here, it's going to be 25 sine of 85 over 15, like that. Okay. And to solve for B here, what do we need to do as our next step? If we want to get just B by itself, what do we need to do to both sides now? arc sine or sine inverse. Exactly right. We're going to do sine inverse to both sides. So we could, if we wanted to, I could just jump right into my calculator here, press second sine, so arc sine or sine inverse, of the 28 times the sine of 85 over 25. Okay, so there I just type, oh, no, sorry, not 25, 15. Okay, so again, it's 25 sine of 85 over 15, just like I got there. I'm doing inverse sine of that. Okay, so I hit enter, and I get an error. Okay, so I can go back here, I can look back here and see, no, I'm pretty sure I typed everything incorrectly. Sine inverse, right, of 25 times the sine of 85 over 15. Maybe I need to put parentheses around my numerator. Maybe I should do that. Okay, so now I've got parentheses around my numerator. So that's just the whole quantity, and then divide that by 15. If I hit enter, still an error. It's saying error domain. So let's take a look then at what's really going on here. If I ignore this, so if I delete the sine inverse part, okay, so let's just say I'm going to evaluate what's over here on the right. Oops, and now I messed something. Oh, I think because I had an extra parenthesis. There we go. Okay, this is what I get. 25 sine of 85 divided by 15 is 1.660. So what that means, I want to know when the sine of b is equal to 1.66, whoops, 0. What's the problem here? Why are we getting an error when we then try and take the inverse sine of both sides here? What's the problem? Why are we getting that error? We're trying to find what angle, so angle B, right? We're trying to figure out what angle, when you take the sine of it, gives us 1.66. What's the problem with with asking that kind of question? What's the trouble there? Well, what's the highest value that sine can be? 1, right? So can there be an angle B that when you take the sine of it, you'll get 1.66? And the answer is no, it's impossible. And so this triangle, right, so there it is, right there. Since we get an error, we reach a stopping point, no such triangle exists. And that's our answer. Okay? So that's what I mean by kind of this case being, I don't want to say, again, for lack of a better word, idiot-proof, right? You will set it up as you normally would. You will try and solve it, and as long as you type everything into your calculator accurately, your calculator, when you go to solve it, will give you an error, okay? If you need to, go ahead and just check that this number here, right? Check that this number is greater or less than, greater than 1 or less than negative 1, whichever might be the case. And if that's the case, well, then you know that it's impossible, okay? That's the idea. No such triangle can exist because this just is impossible. Okay. So that one's pretty straightforward because, again, it happens. It just shows up. All right. So let's look now then at a one solution case. Okay, we already saw this kind of yesterday. Okay, the one solution case. We already kind of saw this yesterday, so it might be kind of, I might be a little repetitive here. All right, but again, we'll just do another example. So again, the directions will be solve the triangle. All right, and again, I'll just draw another triangle here. I'm going to try and draw it a little bit different, just so that way we're not used to seeing the same thing over and over again. Okay, and let's see. Ooh, I'm going to really mess myself up with this, but okay. Okay, so we'll have angle A, B, and C there. I'll say angle A is 42 degrees. The side opposite angle A we'll say is 22. And then we'll say the side opposite angle B is 12. So again, I'm already kind of like, making things or handicapping us a little bit here by telling us this is an ambiguous case situation, right? You guys, when I give you problems to do, when I give you the test, I'm not going to say in the test, which case of the ambiguous case of the law of sines is this triangle? Is it going to be 0, 1, or 2, right? I'll just say solve the triangle. I won't hint at the fact that it could be ambiguous or not. you'll have to figure it out. So what's going to clue us in that this could or could not be ambiguous, right? That we could have no solution, we could have one solution, we could have two solutions. What's going to clue us in? It's the information that we're given. Angle, side, side. Or, you know, if you want to do it again the way that all the math books do it, side, side, angle, right? Side, side, angle. Because they want to spell a bad word. All right. Side, side, angle. All right. So we know that we could have no solution, one solution, or two solutions here because of the given information. We have side, side, angle here. All right, so again, we only have one way to set this up, so we're going to just go ahead and set it up the one way we know how. So we'll say sine of 42 over 22 equals sine of b over 12. Setting up the normal way, the only way that we can. Okay. We have to solve for that angle b first. All right, so again, we'll cross multiply here. Get that, and I'll go ahead and type into my calculator here. Okay, second sine of 12 sine 42. Oops, I should probably put parentheses in my numerator. Over 22, and I get 21.406. We'll say 21.406. Again, if I did the intermediate step here, I guess I'll kind of like do the intermediate step just to show you. Whereas in the past, right, when I did sine of b, I got like sine of b was supposed to equal like 1.660, right? Whereas here, I would get sine of b equals, and again, this is going to be approximate, 12 sine 42 divided by 22. So it would be about 0.365, we'll say, I'll round that because it was like 36498. So it's around 3.365. So again, sine of b equals approximately that 0.365, which is no problem, right? That's between -1 and 1, unlike this one where it was, you know, beyond that. Reduce to second sine of the 0.365, and you get the 21.407 in this case, because I had to round it. Okay, but there it is. All right. And so there's our angle B. And so now that we have that, now that we have that, we can find the other pieces, right? So I know that angle B is that. Once I find angle B, I can now get angle C by doing 180. So the measure of angle C is 180 minus the 42 minus the 21.406, okay, which is going to equal, oops, 116.594. Okay, so I really did not draw this triangle to scale. Then we have one more piece to solve for, and that's the side opposite angle C there. So we'll, again, I would suggest you go back to using the original sine of 42 over 22. Excuse me. And we'll say that's equal to sine of the 116 over little c. Again, we can't use the Pythagorean theorem here, right? So don't try and use the Pythagorean theorem. We don't have a right triangle. The Pythagorean theorem does not apply. Does not apply. All right, so we get c equals 22 sine of 116.594. And so we'll just type that into our calculator. Okay. So C is approximately 29 point, I'm going to say 400. Question? No, that's if you just put 29.4, I would understand it to be the 0, so that's fine. Yeah, that's fine. Yep. Okay, and so there that is. So this one, right, is just like the one we did yesterday. No surprises here. And so you might be wondering to yourself, so how does two triangle, how can we possibly get two triangles in this? This very clearly, we went through this. It seems to just be one triangle, right? Where does a second triangle come in, right? The no triangle case makes sense. If it just happens to set up in the case that, where we have our sine of b is equal to something that's impossible, well, that makes sense. There's no triangle here. The one solution case, again, makes sense. It follows through from everything that we did yesterday, so one solution makes sense. So how can we have two triangles? Well, let me show you. So we'll go to that next one. So any questions thus far, I guess? Any questions thus far on any of that? We're all good on that so far? Okay. And so then the last case. So when we have two triangles. And to be honest, I kind of skipped over something in the one solution case, since we only had one solution. So we'll go back to that one solution case after we now see the two solution case, and just basically compare why the one solution was only one solution and why the two solution is actually going to be two solutions. Okay, so again, I'm kind of helping us out here because we're just learning this stuff, right, that I'm telling you right now this is going to be two triangles. So you already kind of have that forewarning. On a test or a quiz or whatever, it's just going to be solve the triangle. You'll need to know, need to be able to determine what's the case. So let's again start with our given information here. Okay, and again we want to solve the triangle. So again, here you don't have to draw a triangle. You don't have to draw a picture. You could jump right in and start solving it if you wanted to. I like to draw a picture though, just so I can kind of, have my wits about me, so to speak. So let's do that here. I'm going to draw a triangle. So I'll draw it right in here. So again, I'm just going to kind of draw a triangle here. It may or it may not end up being acute like this. Who knows? We're just going to draw and label. So put A there, B there, C there. I know angle A is 20.5 degrees. Side A, the opposite of angle A, is 21. And then side B, which is opposite angle B there, is 30. Okay. So there's our setup. That's also huge, right? You got to make sure you're setting things up correct. So again, how do we know, right? If you were in the wild and you were doing some problems on your own, right? Mr. Wade wasn't there to guide you or lead, over your shoulder or something like that and point something out, right? How do we know this is potentially the ambiguous case? How do we know that this could be one solution, no solutions, or two solutions? Well, the given information. Side, side, angle, or again, angle, side, side, however you want to remember it, okay? It's an angle and then two sides. The angle is not between the two sides. It's, next to them. So it's angle, side, side. It does not guarantee a unique triangle. So we could have one solution, two solutions, or no solutions. So again, we only have one way to set it up. Sine of 20.5 degrees over 21 equals sine of B over 31. Okay, and again, same thing as before. We're going to cross multiply. Okay. We'll end up with that. Sine of B equals that. Okay, I'm going to do this intermediate step here just for this case. Again, I know in the past I told you just go ahead and do arc sine. But I'm going to go ahead and do this little bit of math right here real quick. Okay. All right, so when I do this calculation, I get 0.51697280009. Okay. And so when I do sine inverse of that decimal, okay, I get that B is equal to, again, this is approximate. I should put a little squiggly equal sign there. Approximately 31.129 degrees. Okay, and again, I can check that, right, too, if I go kind of the opposite direction. If I take, so what that means, right, is if I take sine of that 31.129, I hit enter, I get like 0.516966, which is very close, 0.516972, right, like, because I rounded this number, that's why this is not quite the same as that. But it's pretty darn close, right? So that's the idea. Sine of this angle will give me that ratio there. That's how we got that in the first place. We did sine inverse. But here's where the second case comes in. Here's where the second triangle can come in. Okay, there are two quadrants where sine can be positive. The first quadrant and what other quadrant? The second quadrant. And the second quadrant contains angles that are less than 180 degrees. And therefore, they could still be angles in a triangle. Right? So, how do I figure out what this other potential angle could be in the second quadrant, right? If this is my angle, this is my quadrant 1 angle, the 31.129, how can I figure out what the other one is? Well, you just do 180 minus the 31.129. Which is equal to 148.871. So there are two possible angles. Okay, and again, if you don't believe me, I'll type it in here. Sine of 148.871, right? Just like is 0.516966, just like sine of 31.129. Okay, they're the same value. Right? So why does our calculator only give us the 1? Why does the calculator only give us 31.129? Well, it's because the arcsine command, right, when we do arcsine on both sides, arcsine, if you remember, sine goes from negative pi/2 to pi/2, so it only gives us answers in the first quadrant. But because this is like an equation setting, we want all the possible solutions for B here that would work. So there's two angles that work. There's two angles that work. Those two. 31.129 and 148.871. How do I know that both of these work? Well, if I go here and look, right, would 31.129, you know, quote unquote, make sense here? Would it make sense to have a 31-degree angle here? Well, the side of 31 is opposite that 31-degree angle. 31 degrees is bigger than 20.5 degrees, and 31 is also bigger than 21. You see that, right? The smallest angle should be opposite the smallest side, and then in this case, the next biggest side here should be opposite bigger angle, right? So we have a smaller angle and then a bigger angle here. We have a smaller side opposite the smaller angle and then the bigger angle opposite the bigger side. So yes, the 31 works there, but so does the 148. All right? It is possible to have both of those working there. All right? So why didn't we check that in the first case? Well, technically I should have. So technically, if I go back to this one solution case, when we did this angle B here, I should have also checked to see if 180 minus 21.406, if 158.594 would work here. But if we look at angle B here, in this case, angle B is opposite the smallest side, right? So if angle A is 42 degrees and it's opposite the 22, it would not make sense for angle B here to be 158. That'd be too big. You're saying that a bigger angle, 158, would be opposite the smaller side. That doesn't make sense. And so it only is the one solution there. It's only the one angle, 21.406. Okay? So that's the idea. It will not ever be the case that the second angle will work, but the first angle won't work. Alright, it'll never be the case that the second angle will work, but the first angle won't work. So either it's only the first angle you get, the 21.406, or it's the case where the first angle and the supplement to that angle will both work. Okay, Okay, and it all has to do about whether the angle makes sense in the triangle, right? Here again, the 21.406, that one made sense because it was a smaller angle than the 42 that we started with, and it's opposite the smaller side, 12, right? Whereas the 42 is opposite the 22. So the bigger angle is opposite the bigger side, the smaller angle is opposite the smaller side. Here, because of the way our triangle is set up, A is opposite the 21, okay, so B, since that's bigger, B just needs to be bigger, that's all, than 20.5. So B could be the 31, B could be the 148. Okay, so that's why we have two possible triangles here. And since we have two possible triangles, we get to solve for both cases, okay? So we're going to solve, solve our triangle so that B is 130, or 31.129, and then we're also going to solve so that angle B is 148.871. Now we're just going to, but the good news is at this point it's the same kind of problem now. You just solve it. You have to solve two basically. Okay? So any questions up to that point? Does that make sense about why we have two possible triangles here? Is there anything unclear about that? All right. So that's the idea here. Okay, and you might have more questions once I get you started on your assignment and stuff too. But anyway, so now we have that. You know, we can kind of, let's see here, I might just redraw the triangle just so I can have it handy. Okay, so 20.5 degrees, 31.129 degrees, 21, 31. Okay, so now we can find, you know, angle C pretty easily. We'll just do 180. Okay, and so you get that angle C is going to be 128. .371 degrees. Okay, and then once you have that, I'll kind of squeeze it in here. We can now find side C. So again, I would recommend you start with the given information. So sine of 20.5 over 21 equals sine of 128.371 over C. And you just cross multiply and solve here. And we get about 47.013. And again, if we examine this triangle makes sense. The smallest angle, A, is opposite the smallest side, 21. The biggest angle, C, okay, is opposite the biggest side, little c right there, the 47.013, and then the middle angle, 31.129, is opposite the middle length side of 31. So this triangle makes sense. Okay, so it kind of works there. All right, and then alternatively, we have our other measure for angle B, kind of like our alternate universe one. Okay, again, I'm not even going to bother trying to draw the scale. We'll just trust our labeling. So again, instead of using the 31.129, we'll use the 148.871 for B. Okay. And so the measure of angle C then will be 180 minus 20.5 minus the 148.871. I get like 10.629. And we set it up and solve just like we did before. So we'll say, you know, sine of the 20.5 over 21 equals sine of 10.629 over little c. Cross multiply and solve. Okay. Okay, and I get like 11.060. How fun is that, right? Pretty nice. You'll see again that C switches, right? C switches. So C in the first triangle ended up being the biggest angle, and then side C ended up being the biggest side. But then in the second triangle, angle C had to end up being the smaller angle, and then therefore be opposite the smaller side. Okay, but it still fits. It still works. Still works. Okay. Should you in a one solution case, should you accidentally like pursue a two solution case? So should you be given a triangle like this, and you go ahead and you just like end up doing the two solution case, like you kind of follow this 21.406 and do a triangle for that one, and you follow this and do a triangle for this one. When you then finally have your two triangles like filled in, you'll look at this second triangle and you'll notice that it can't make sense. It won't make sense. Okay, this angle of 158 degrees will be in here for B, which is opposite the 12, but you'll also see that 42, a smaller angle, is opposite a bigger side, which can't happen in a triangle. The smaller angle is always opposite the smaller side, the bigger angle is always opposite the bigger side, and then the middle angle is opposite the middle side. So if you happen to follow the wrong path here and mistake a one solution case for a two solution case, if you examine your answers at the end to see if they make sense, you'll have a triangle that doesn't. And so you can just like X that out if you want to, and then just keep the one solution case. That's fine. Okay? So you can kind of feel your way through here. It's not a guessing game. Okay? You can kind of feel your way through. Your triangle should make sense in the end. All right? So let me give you guys two to try here. Okay? I'm only going to give you two, so you have no idea which one is which. Right? If I gave you three, you would know, of course, one would be one of each. But now, you have no idea. Or maybe you do. Okay, so we'll say A is 60 degrees, little a is 4, little b is 14. Okay, and again, we're just going to solve. The given measures, or using the given measures, I guess. So that'll be the one, and the other one is A equals 58, little a is 4.5, little b is 5. So right away you can see it's angle side side or side side angle, whatever you want to say. Okay. So you're going to have, the three different scenarios possible. No solution, one solution, two solutions. Yes. Good day, sir. Sure, if you guys are using it, yeah, I'll take one. Oh, sorry. 30, please. Okay, thank you. Bye. Here, 1 more minute. Working. 1 more minute. Okay, so for the first one here, oh, no solution. Yay! And then boo. All right, 2 solutions. And they both make sense, right? So when we result, and well, I guess I should get the things labeled here appropriately. Okay. Both situations make sense, right? Starting with the A, 58 degrees, and its opposite side 4.5, and given that opposite side of B is 5, okay, both the 70, right, which is bigger than 58, so therefore that makes sense that the 5 is bigger than the 4.5, and the 109, which is bigger than the 58, again, 5 is bigger than 4.5, that's okay. They result in C angles that are 51.563 or 12.437. Either of those, okay, also, they're both smaller than either of the 2 angles in the triangle, and so they result in the smallest side as well. Okay. So, questions on any of that? That makes sense. Nick?
Yeah, I don't know how you got that.
Okay, so let's see, were you able to come up with that, here in the initial calculation, that B had to be 70.437?
Well, I have the same thing.
You have the same setup here?
B, yeah, that's what sine of B equals, but then I got B equals, like, I got an error. Like, I got, like...
Oh, you did? You got an error?
Yeah.
Okay, so I would say, well, so first of all, make sure that your mode is set to degrees and not radians. Yeah, so there it is. Yeah, and we talked about that yesterday, so, but since, yeah, I'm sorry, didn't mention that, yes. Everyone else was probably still set to degrees because of yesterday, so. If you set it to degrees, it should fix it then. Sorry, Nick. All right, so that's the idea there. Any other questions on any of that? Is that making sense? All right. So again, how do we know that we have this case? Angle side side or side side angle, however you want to remember it, right? That's the starting information that you will have. Not all law of sines problems require angle side side. For example, or start with angle side side. The warm up that we did today. All right, the warm up that we had. Well, yeah, I guess I kind of had it up here, but it was a this is a different thing. Never mind. But it was we had it was an angle side angle or angle side, one of those two. I think it was angle side is what it was. Yeah. So anyway, different situation. That the warm up situation guaranteed a unique triangle because it's a congruency. Okay, so only one triangle could exist that's like that. But here, because these are not congruencies, angle side side or side side angle is not a congruency. Other things could happen. right? And so here are these other things. All right. So there's one other thing I want to show you. We're just going to like briefly touch on law of cosines. Law of cosines will not be on tonight's homework, but I at least want to get started on it just so we can have it, and then we'll finish law of cosines tomorrow. Okay. So law of cosines is an alternate way to solve triangles. Okay. Like I said, this will be the last little bit that we concern ourselves with here. All right, and we'll stop. I'll just show you one problem with it, and then we'll do more tomorrow. Okay? So law of cosines, it works for side, side, side triangles and side, angle, side. Right? So for example, side, side, side triangles, if we're given three sides of a triangle, we're stuck if we try to use law of sines, because law of sines requires that we know angles too. Right? So side, 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 we don't have enough information, but we can use law of cosines for that. Side, angle, side, again, we're stuck, because to use law of sines, we need a angle and opposite side pair, which side, angle, side, we don't have an opposite angle and opposite side pair. We just have the angle between the two sides there. So, what is the law of cosines? Well, the easiest way to introduce it to you is to write this. Okay, we all know that is the what? Or it looks like the what? Pythagorean theorem, right? Okay, and in fact, if we had a right triangle, that's all we needed. That's all we would need, right? We could just use that to find, our solution. But of course, we're talking in general about any kind of triangle, not necessarily being a right triangle. And so we can't just use Pythagorean theorem for any triangle. So to this, we introduce a bit of a correction. Okay? And this is the law of cosines. Okay. It's one way you can think about it is that it is just the Pythagorean theorem with a correction for the triangle not being a right triangle. Okay? So that's one way you can think about it. Good day.
Here's some things.
Thank you.
Enjoy.
I will. Oh boy. Are you guys planning on using the book at all to teach this, or are you just kind of...
I'll speak for me, no.
Okay.
Maybe for multiplication.
Okay. Gotcha. All right.
But what do you think?
I'm up to either one. I don't know. We'll see.
I could be this way.
The book's got some like parky word problems in it. That's the only
I think
thing.
we have to use those for the applications they're going to plan on next week.
Roger that.
But
Okay. Gotcha.
for like just doing it, there's
For
not enough rest.
just doing it. Gotcha. Okay. Gotcha. All right. So, all right. Now, that's one iteration of the law of cosines, but we also have others. Make sure I did that one right. Yes. All right. And then also with a squared. Okay. And it turns out all of these relationships hold true. And of course, I'm talking about, a triangle like that, where you have angle A and opposite is side A, angle B opposite side B, and angle C is opposite that is side C. Okay, and so now we have enough, laws, so to speak, that cover all of our congruency situations, right? Law of sines, that covers situations where we have angle, angle, side, or angle, side, angle. Law of cosines covers where we have side, 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 or side, angle, side. And of course, hypotenuse leg, that's right triangle stuff, so we can use whatever we need there. Trigonometry. So let me just show you one quick example of how to use this. And let's just say we've got just a quick example here. Let's say I've got a 45-degree angle here, and I've got this side is 19. Whoops, this side is 46. And I don't know, I'll say that's A, and this is B, and this is C. And we're not going to solve for the whole triangle here. Let's just solve for side A. Let's just solve for A. Okay. So right now, what we can't use is law of sines. Can't. Because in this case, we have angle A, but we don't have the opposite side, little a, right? So we can't start there. We couldn't use B because we have side B, but we don't have angle B. And same thing here, we have side C, but we don't have angle C. So we're stuck. Law of sines does not work here. Yet, we need to find this side A to start out. Okay? And so we want to be careful about which one of these three formulas we choose, okay? For example, if I just choose willy-nilly here and I just pick this first one, all right, I can plug in the values I know. So let's see, if I choose to use the c-squared version of the formula, we're going to run into a roadblock and you'll see what happens. So if I plug in what I know, so little c is 19, little a, we don't know, we're going to solve for that. Little b is 46. And again, little a we don't know. Little b is 46. And then cosine of angle C, which we also don't know. What is the problem with trying to solve this equation? What's the problem that I have here in this equation I'm going to try and solve? I want to know what A is, but what's the problem? If I solve for A, what am I going to run into here? I mean, one maybe thing is going to be that we have A squared and we just have just A, so that's going to be kind of weird. Caleb?
You don't know angle C.
You also don't know angle C. Okay, we can't solve an equation with two unknowns in it. We can't solve a single equation with two unknowns in it. So we don't want to use this version of the formula. Alright, so which version do we want to use? Well, if we're trying to solve for A, you want to pick the one that's got A squared equals. So this was the wrong way to go. But if I use the A squared one here, then, so that's going to be B, okay, so it's going to be 46 squared, plus then C squared, 19 squared, minus 2 times the 46 times the 19. Cosine of, angle A is 45. We know that one. And so I can just type this into my calculator here. 46 squared plus 19 squared minus 2 times 46 times 19 times cosine 45. I get A squared is approximately 1,240.977. And I'll just square root that. And A is, again, approximately 35.228, we'll say. Okay, so there's an application law of cosine. Right. At this point, now that we know that is true, that is where the 35.228 goes, what can we use at this point to solve for the remaining pieces? What can we now use to solve for the remaining pieces here? If I want to solve for angle C, if I want to solve for angle B? Law of sines. Now, we could use law of cosines if we wanted to, but law of sines, because obviously law of sines is a lot nicer than having to write all that mess out. So you would use law of sines. In fact, you'd only need to use law of sines once, because once you find the angle C, you could then easily find angle B. Once you find angle B, you could easily find the angle C by subtracting from 8. So that's that. Okay, so all done. Okay, law of sines, law of cosines. Good stuff.